Principal, and to all attendees present over here. Here we all gather together for the pleasant and progressive arrangement of Faculty Development Program on Fundamentals of Cloud Computing and Emerging Trends with Cloud Technology, technically and financially sponsored by AICTE ATAL. This is not just a platform for learning, but also it's a journey towards excellence, innovations and collections. With respect, I like to honor our esteemed guests who have been pillars of support, sources of knowledge and an inspiration for all of us. Please give a big hand for Dr. Thanekar sir. Dr. Thanekar sir is our expert speaker for today. I request our respected academic dean and honorable vice principal, Mr. Balaramu sir, to felicitate our speaker, Dr. Thanekar sir. So please come forward. Please give a big hand. Thank you, sir. Please have a seat. Now I request Ms. Pansare ma'am to introduce our expert. Ma'am, please come forward.
Good morning, everyone. A very warm welcome to all present here. It's an honor to grace by the presence of such an accomplished speaker. The Faculty Development Program isn't just a platform for learning, its journey toward excellence, innovation and collection. Today's expertise is Dr. Sachin Thanekar sir, a highly experienced professor who has demonstrated the ability to teach students to new level of success in a variety of highly competitive industries, cutting-edge markets, and fast-paced environments. He has completed PhD in CSE at Vijayawada. He is the assistant professor at Amrutvahini College of Engineering. They have 15 years of experience of teaching. He had also published some books at national level and international level regarding CS, AI, database, etc. Since from 2014, he also published some paper in reputed journals. So now let's welcome them with an applause. Thank you so much.
Thank you, ma'am. Our yesterday's session was successfully concluded by Dr. Korde sir and Dr. Vakchore sir. Now Dr. Thanekar sir going to conduct our today's session. Here we are going to start morning session till 12 o'clock. We will start article discussion on 12 o'clock. After that we have a small break for 1 hour for our daily shares. Now I request our expert speaker for today, Dr. Thanekar sir, please start the session.
I would like to congratulate your HOD, Kavita Khatal madam, Vice Principal, Balaramu sir, management, all the staff members and all the students who have taken this initiative and which is the need of the hour and which is the essential part of any academics. And it is really a great thing that it is happening in your college. And I am also thankful to all of you for inviting me and giving me opportunity to share my knowledge as well as discuss the current issues in the virtualization in the most popular field, that is cloud computing. And today I am not going to teach you anything, I am not going to ask you any questions and you will not have to answer anything. Rather it is a discussion, it will be a discussion, and feel free, feel relaxed and sit back, relax. So need not to bother about anything at all. We will go step by step ahead and we will discuss the current trends in the cloud computing field. And the topic given me is the virtualization, and which is the almost base of each and every application in the market. And all the applications are currently working on this virtualization concept only. Already my introduction is given to you, So I will not waste much of time in that again. So let us start with our session. So these will be the contents of our presentation. So I am going to cover all these contents in our presentation, starting with the definition of virtualization, then why virtualization, types of virtualization, architectures which are helpful in virtualization, then the most important, grid, which is the supportive technology for this cloud. So difference between that grid and cloud, then how virtualization cloud are helping us in different fields. So like this, we will proceed further and we will try to cover all these concepts in our today's session. So before going to actually start our session, I would like to revise whatever different speakers must have told to you and the basics which are there in cloud with the help of one video. So let us first start with our session, and later on I am going to share this video with you as well. It will not take much of time, and then we will go back to our session of virtualization. Okay? So basically, this video is giving you idea about the basics of cloud computing. I'm actually stopping this video here. This was earlier to cloud computing when you were there in schools. At that time, we used to send email like this through our Microsoft operating system only. And you must be aware about Outlook and all those kind of softwares were there. Still they are there. So we have to configure that part in our computer system, and then we were able to send emails. Now how that scenario is changed by cloud computing? That is the next part of our video. So this is earlier to cloud computing. We have operating system, we have email software in our operating system, and we have our computer system itself. So we can consider that as a server. And then we are trying to send some email through that system. Now how cloud computing changed that scenario? That is the next part of this video.
Exchange. And then after some configuration, you will be able to use email. But the problem is that if anything goes wrong with the server, such as a hardware failure or a software problem, or if the operating system crashed, then you would be responsible for fixing the problem, not to mention any maintenance that's needed to keep the server up and running. However, you do have the option of eliminating all the hassle and upkeep of your own email server.
Now here, if anything goes wrong from our end, that means if our computer system fails, or our software fails, or anything goes wrong from our side, we are not able to send it. And moreover, the responsibility is of ours how to fix that. Are you agree? This happened earlier to cloud computing in our childhood. So we used to send emails like this. Now how cloud computing changed that scenario? Nowadays we are sending emails through different platforms like cloud computing platforms like Gmail, through different Google services, through different web portals. And if anything goes wrong, it's not our responsibility to handle that. That responsibility is of providers, service providers. So if something goes wrong in Gmail, we are not responsible to handle that fault, or we are not responsible to correct it. Rather, it is the responsibility of the service provider. So what is the beneficial thing here? Whatever headache was there at our end, now that headache is removed by cloud computing. And cloud computing takes care of all these things at their end. So it is very easy for user to use systems like this. And that is told in this video.
Host all of your email on their servers in the cloud for you, such as Gmail, Hotmail, and a bunch of others. But email is just one example of cloud computing. There are also other services, such as productivity software, web servers, databases, and even YouTube. So yes, you as an individual can use YouTube as a cloud. So if you're a video creator, and instead of building and maintaining your own video server and software, and the extreme high cost of internet bandwidth that you would need for people to watch your videos from your server, you can bypass that and you can just upload your videos to YouTube and let YouTube handle everything for you. But instead of directly paying YouTube like a regular cloud provider, YouTube will get a share of the ad revenue generated by your videos. So another question is, why would an individual or a company use cloud computing? Well, as I just mentioned, a major reason is cost. With cloud computing, a person or a company eliminates a lot of the expense of buying their own hardware and software, along with the building, maintenance, and electricity it takes to run their own data center. So it would be more cost efficient to use a cloud instead. And another reason is reliability, because when you hire a cloud, the cloud provider is responsible for all of the data backup and disaster recovery. And if one of its data centers goes down, they will also have several redundant sites as a backup, which will ensure that there is no downtime. And another reason is scalability. Cloud providers will offer a pay-as-you-go method, where you can pay for only what you need. So whether you need to rent a few computers or a lot, it doesn't matter. So if you only want to rent a small amount of computers to start out, you can do that. But as your business expands, you have the option of instantly renting more computers to suit your needs. And if you don't need to rent as many computers, you can instantly scale back to renting only a few. So who are the cloud providers today? Well, the major cloud providers today are Amazon Web Services, or AWS, Microsoft Azure, Google Cloud Platform, Alibaba, and IBM, with Amazon Web Services being the biggest of them all, taking about a third of the cloud market share. In fact, one of AWS's biggest customers is Netflix. Netflix uses Amazon Web Services for nearly all of its computer and storage needs, including databases, analytics, video transcoding, and so on. So instead of building its own data center and spending hundreds of millions of dollars on hosting its own data, Netflix chose to outsource it to a cloud provider, which is Amazon. So a major advantage that Netflix has of using a cloud is that they don't have to worry about downtime, security, data backup, or the high cost of building and maintaining their own data center. They can just pay Amazon to do it for them. So this takes a tremendous burden off of Netflix, which allows them to focus on other things pertaining to their business. Now, there are three different types of cloud computing. There's infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. And these three vary in control and flexibility, so it's up to the user to decide what suits their needs. So the first one is infrastructure as a service. Now this type is basically where you're going to let the cloud provider manage a portion of your business, which is going to be the hardware portion. The cloud provider will manage the servers, storage, virtualization, and the networking portion. You, on the other hand, will still have control over the software portion, such as the applications, data, operating system, middleware, and runtime. Some examples of infrastructure as a service that the common person would use would be online data backup services, such as iDrive and Carbonite, that provide cloud storage. And the next one is called platform as a service. Now, PaaS, like IaaS, allows the cloud provider to manage a portion of your business, but the cloud provider has more control. In a PaaS, the cloud provider not only manages the hardware, such as servers, storage, and networking, but it also manages the operating system, middleware, and runtime. You, on the other hand, are only responsible for the applications and the data. And finally, there's software as a service, or SaaS. Now, this is probably the most common cloud service by far. In this type, all the applications are hosted by the cloud provider. There is no software to install on your computer and no hardware to manage. You just simply access and run the application from your computer when you connect to the cloud service through the internet. So the cloud provider manages all the hardware, software, networking, operating system, and storage. A good example of SaaS is something that I use all the time, which is Google Docs. Google Docs is a free online office suite that is accessed using a web browser. There is no additional software that needs to be installed on your computer to use Google Docs. Everything is accessed and managed from your web browser. So this concludes the video on cloud computing. Please subscribe and thank you for watching.
So why we revise these basic concepts? Because all these basic concepts are directly related to this technology of virtualization. And you must have seen 3 different services: software as a service, platform as a service, infrastructure as a service. But all these services can be virtualized. All these services can be virtualized. And we can save our resources by this virtualization. And that is the core of cloud computing. That's why we revised all these basic concepts. And from there, you came to know that the most popular applications like Google Docs, Amazon Web Services, Netflix, almost all the applications you people are using, Gmail system, so all are the best examples of cloud computing services. And all are using virtualization for their purpose. And that's why virtualization is the core of cloud computing field. So let us start with what actually virtualization is. It is a creation of virtual machine. Creation of virtual machine rather than creating something physical. So it is just a virtual thing, just like our software. Software is a virtual thing. And we cannot feel it, or we cannot show that this is a software. It cannot show like that. Hardware we can easily show that. So it is just like that. We can create our virtual image of some application or of some operating system or of some virtual instance of some hardware or network. So that is the virtualization. And advantages of virtualization that we will see later. But virtualization means we are creating something virtually, not in real existence. So this is the scenario where cloud computing helps us in different scenarios like this. Hardware virtualization, operating system virtualization, cloud server itself is a kind of virtualization, storage virtualization. So for anything we are using like that. Just here it is shown that Netflix is hiring cloud computing services for their movies, storage of their movies. And even if that Netflix server fails, still they are able to show that movie through some another storage devices. So they have virtual instances of that same movie at different locations. And you might have came across the word replication or replica. Have you ever heard these words somewhere? In cloud computing, we always store replicas of our original data. And if one data fails, we can get it through some another replica. If that fails, we can get it from some second replica. So like that, the most commonly used factor is 3. 3 replicas are kept in the system. And if all 3 fails, that means it is assumed that the whole network is failed. But in this fashion, they are managing all our continuous services. And virtualization plays very important role over there. So for that, they require virtual machine. For that, a second hypervisor, which provides all the functionalities. In other sense, you can say which provides operating system for cloud computing. In general sense, you can say that it provides some operating system for virtualization. And on the machine itself, we can create some virtual machines. How that we will select on. Then we must know the concept of container. Container, the name itself is indicating that we are combining or we are storing whatever are the required fields or services or applications in some place, and we are referring that place as a container, just like a box. Whatever we need at the time of traveling, we are putting all those things in some bag. So bag is container for us, and we are carrying those containers. So whatever we need, it is there in that container, and with the help of that we can do whatever we want to do for our purpose. So it is just like that. Container is that concept where all the applications, all the softwares, all the required documents, all the required files, all the required configurations, everything is placed inside that container, and through that container then we can simply refer that container and we can get our services. Then we must know virtual network. The name itself is indicating it is virtual. It is based on some real network and its instance is created. You might have came across the word lightweight process. Have you heard? Thread is a lightweight process. Have you heard it somewhere? Thread. We have different processes in our system and we have threads also in our system. So thread is known as lightweight process. So these virtual things are just like those lightweight processes. These are the threads created on some real infrastructure. And we are simply putting only those things in that thread which are required. For example, I want to read my email only. So this is my requirement. So I need not storage or I need not to do with other things which are there in the system or on the cloud system. Simply, whatever things are required to read that email, only that will be placed in the container, and through that container I am able to access my email fully. So that's why we can check emails very fastly, because only required things are kept in that container and we need not to bother about other things. So whatever you need, simply focus on that and place it in container. Then for all such things we need some kind of software, and most of the students must be knowing about VMware. Have you heard? VMware Station, VMware Workstation, VMware software, which is generally used for virtualization, and through that we can have multiple applications, we can have multiple operating systems, we can have multiple resources on our computer system. For example, I want to create 10 machines, and it is not possible for me to have those 10 machines physically somewhere. So what I can do with the help of virtualization, I can create 10 different instances of my operating system or whatever software I want. I can create 10 those such instances, and I can assume each instance as one machine, and I can get my work done from it. Example, I want to test my application, and the requirement given by the customer is that at a time 100 customers can log into my system. At a time 100 customers can log into my system. So it is the requirement. So from where you can bring 100 computers at a time? Is it possible physically? For big organization it may be possible. But in order to test whether my system will work with 100 users or not, I have to create 100 machines, or I have to bring 100 physical machines for my job, and then only it will be possible to check whether my application will work fine or not. So in such scenarios, this virtualization helps. We can create 100 instances with the help of virtualization, and with all those instances we can check our functionality, whether all those 100 instances are working at the same time, whether our cloud is able to provide services to all those 100 instances at a time. and as it is the instance created by us, we have to define that instance, we have to manage that instance, we have to configure that instance, and for that purpose we need virtualization software. And that virtualization, in other sense, it is just the mediator between your operating system and the thread which you have created through the virtualization. And it acts as a middleware in between your operating system, which is there on your computer system, and the virtual operating system which you have created with the virtualization. So it is just the middleware between these two, and that middleware helps us to manage our things. It is just like a simple scenario where you are giving all the instructions in English like language to computer system, but computer does not understand English like things. Computer only understands zeros and ones. So whatever you speak, whatever you type, all those things are converted into zeros and ones. So it is similar. It is that kind of converter which converts those English like things into zeros and ones. Okay? So it is just that kind of software. It is just that kind of software where it is converting our request to the request which is understandable by our original operating system, and whatever output is given by that original operating system, again it converts to virtual system. So it is the mediator in between these two. So that is virtual, and VMware is the best example. You might have observed VMware somewhere. Then what is the concept behind the virtualization? First you read this carefully, then I will come back to it. You read this carefully first. Have used these two concepts since your childhood. That is, in your Windows operating system, there is administrator account and there is guest account. Am I right? Yes. Administrator and guest. If something goes wrong with the guest account, still our system is working fine with administrator account? Yes. You might have observed. Am I right or wrong? Right. So, whatever you want, all such kind of things are given to you with a separate thread, that is separate virtualized instance of our Windows operating system, and that is known as guest operating system. Guest operating system. And it is totally based on the host operating system, that is your administrative account. And you all have experienced these kind of things since your childhood. So even if you install some software in guest operating system, even something goes wrong, even if you delete something from the guest operating system, it will not affect the original operating system. It will affect only your account, your guest account. So that is the virtual instance created in our operating system. And cloud is also doing the same thing. The original operating system, the original hardware, all those things remains stable. They have given you simply an instance, and you have to deal with that instance only. Is it clear? Yes. You are dealing with the instances, and you are not dealing with the original hardware or original software or original cloud servers. You are simply dealing with the instances, and you are the responsible person to use, how to utilize, how to configure. Simply they are providing you the services. In what way you can do that, or in what way you can configure that, or in what way you can customize it as per your own need. They have given you, say, you purchased 100 MB space on cloud server for your website. So you are given access of 100 MB only, and it is your right how to manage that 100 MB. If there is some error, they are going to help you. That you can minimize your error like this, you can configure this like this. They are providing services for that. But if something goes wrong in that 100 MB, they are not responsible for, because you are the owner and you are dealing with the instance. Rather, what they can do then in that case, they can give you option recover, they can give you option reset, they can give you a fresh new 100 MB space. Are you getting my point? So you are the responsible person for your instance, and virtualization is giving us that kind of facility. So it is in total control of the user, and virtualization is providing simply instances for that. So here example is shown for hardware instance. In the definition, hardware instance, where an instance of some hardware is created and you are simply placing some request for that. The best and the very basic example of this hardware virtualization you might have seen in some cyber cafe or in your college also. There is one shared printer. There is one shared printer, and different people are giving different commands through their own computer systems on the same printer. On the same printer, and still our printer is able to print. So it is hardware virtualization. Are you agree? And that virtualization is made available on cloud. So it becomes cloud hardware virtualization. That's all. Now what happens if your system restarts suddenly after giving printout command? So whatever happens, it will be your system only, and your hardware printer will not be affected at all. It will print other people's also. Am I right or wrong? Only your request will be removed from that queue as your system is restarted. So your instance is simply removed from the system. Otherwise, printer will work. It will work with other instances as well. Is that clear? So that is the advantage of virtualization in cloud computing. Cloud computing is very big thing. In that big thing, the whole access is not given to you. Rather, an instance is given to you, and you will be responsible for that instance. And you can handle that instance by your own way. Like Gmail, we are not having complete access of Gmail system. Are you agree with me? You are not having any access on complete Gmail system. Rather, a simple instance is created with your account, and you are responsible for your account only. So if something goes wrong in your account will be reset again, or it will be recorded again. But other people can use that Gmail system very effectively. So it is just like that. So these are the benefits of virtualization in cloud computing. It is flexible and efficient allocation of resources. Flexible, we can use it anywhere. Resources can be used when it is required. It can be released whenever we do not require it more. So like that, it will be very flexible. And in that video, initially I showed you one video. Scale up and scale down is one of the features of cloud computing itself. Scaling up and scaling down. I have 10 computers in my lab, and I want to add 10 more computers. I can easily add those 10 more computers in my cloud computing scenario. If I don't want that 10 again, I can remove those 10 again from the system. But system will work fine. System will not be affected at all. So easily I can scale up, easily I can scale down. Easily I can go for some new things in the cloud. So like that. The best example is this flexibility is the updates provided by say antivirus system or Windows operating systems. Flexible. By providing those updates, your system will not be removed from your system. Operating system will not be removed from your system. It will work. Only it will apply those updates whenever you want. If you say after 7 days, it will install those updates after 7 days. So it is flexible, and you can use it anywhere. Enhance development productivity, as we need not to bother about fault tolerance. We need not to bother about error handling. So it is very easy and we can increase our productivity. Instead of spending time on error handling, we can spend that time on productivity and we can go for some another work, more productive work. The errors, the fault tolerance, all these aspects will be taken care by cloud providers and they will do that for you. So you need not to bother about those things at your end. Simply instance is provided, you access that instance, get your job done. If something goes wrong, report to that cloud provider will solve that. Simply again you get back your services. So it is like that. If we have all the things at our end, what we have to do then? If something goes wrong, we have to handle that error on our own. We have to remove that error. So it takes more time, more cost, more people, wastage of time. So less productive method. So it is better to go for services like cloud where they are taking care of all these things. Then it lowers the cost of IT infrastructures. You need not to spend money on the IT infrastructure. Say you want a lab of 10 to 20 computers with Linux operating system. So it is very difficult because to bring new 20 computer systems, or if you have 20 already, to install new 20 Linux operating systems on it. It takes more time, more resources, more efforts. So you need not to pay for that. So you simply pay some amount to cloud providers. Cloud provider will provide you 20 instances where you can use Linux operating system. You get your job done through those 20 instances or through those 20 virtual machines and your job will be done. So it saves your time, cost, resources, everything. That's why nowadays you might have observed there are companies started in 1 BHK flat, in 1 room or 2 rooms or in 1 shop. You might have observed. It is possible because of this cloud. In just a 10 by 15 shop, 10 by 15, are getting what I am trying to say? It is just a 10 by 15 office. They are dealing in crores. How it is possible because of cloud computing? Because they are not investing anything on infrastructure. They are hiring infrastructure through cloud services. And they are doing their projects on those clouds. And people sitting back at home, they are doing their jobs from their homes. And they are earning in crores. Just a shop of 10 by 15, 15 by 15. Through those shops, they are earning in crores because of this cloud computing. Because they need not to invest anything at all. Simply they are hiring services from clouds. They are storing their data on clouds. They are getting software services from clouds. They are getting ready-made environments from the clouds. They are getting ready-made code samples from the clouds. Everywhere it is available. And nowadays, the best example of one more cloud computing application, ChatGPT. And almost every person is using ChatGPT. Am I right? My 7-year-old son taught me ChatGPT. Initially, I did not know about ChatGPT and I was not using ChatGPT at all. But my son is always watching some reels, videos, YouTube videos, shorts, and somehow he came to know about ChatGPT. And he heard something, he saw something there, and he told me that I can generate contents of PPT through ChatGPT. And my teacher told me to bring ready-made PPT for tomorrow's function. Then I searched how I can generate, and it gave me outline for that. And I prepared my PPT. So this much is the ease that a 7-year-old boy can use cloud computing. So this is the ease. Then rapid access, remote access and rapid scalability. As I told you, sitting back at home, you can do your work. So remotely you can access everything. Remotely you can do. Remotely you can add resources. Remotely you can remove resources from the system. So this much is the simplicity of the application. Then it is highly available all the time. And disaster recovery. If you remember in that initial video, it is shown that if something goes wrong in your computer system earlier days, like you want to send simple application of email, you have to configure your Outlook, you have to configure the settings, you have to give host name, you have to give IP address, everything you have to put it in your computer system. And if something goes wrong, it is a big headache. So cloud removes all such barriers. All such barriers. If there is something wrong in Gmail, Gmail will take care of that. You need not to bother about that. Gmail will solve their own problems. Then the most important nowadays, pay per use of the IT infrastructure on demand. Pay per use. The basic example of this pay per use is your set-top boxes. Am I right? Set-top boxes. If cricket season is going on, you simply start your Star Sport channel, and if cricket season is over, you stop that service, stop paying for that service. You can add your channel whenever you want, you can remove that channel whenever you don't want that channel. So pay per use. If you want that service, at that particular point of time you pay it, use it, stop it. So it will be charged for just for that period of use. So pay per use. Then enables running multiple operating systems. As I told you the example of VMware. Through that VMware, I can use multiple operating systems on a single computer system. And I can use Linux on the same computer system. I can use Windows on that same computer system. I can go for Mac on the same computer system, and I can use all the systems at one point of single point of. So that is the advantage of it. So through virtualization it is possible. Now let me show you the simple example of virtualization, and you can understand. So this is my Windows 11 operating system. I install VMware. Just see it. A VMware. That yellow sugar. I am starting that VMware. So as I told you, I have created a virtualization in my own office. Similar virtualization is done in cloud space. So it is cloud virtualization. I am showing it on a standalone system only. That is the only difference. Otherwise, there will not be any difference at all. Similarly, it will work. So see here, I have created one instance Ubuntu. Okay, Ubuntu. I am starting that instance. So VMware is starting Ubuntu operating system in my host operating system Windows 11. Which is my host operating system? Windows 11 is my host operating system. If something goes wrong in that virtualization, still my Windows will work fine. Is that clear? So let me show you. It is booting. So similar things can be done in cloud environment. I am showing it in on single computer mode. So cloud is also doing the same thing. On cloud, it is providing us instances like this. Now see, at the same point of time, I can do work with my Windows operating system. I can do work with my Linux operating system. Suppose I want 100 such instances. 100 such instances. I want 100 computers and I want to test my application that whether my website is supporting 100 users at a time. So through just my single computer system, I can create such 100 operating systems, such 100 instances, and I can start all the instances, 100 instances at a time, and I can configure them that access this website like this. There are many different softwares available. Just auto clicker, you might have observed auto clicker. Automatically it will click on something and the functionality will play accordingly. If you want to increase number of likes on your post, simply auto clicker software is there. It can log in with new user, it clicks on like, again log out, again create new user, again clicks on like. So just like it is a automated software, and it keeps liking on your post, and just in that fashion your likes are increased. So people are providing that kind of services as well, where they are charging for it. So here this Ubuntu is just single instance, and it is created with the help of virtual machine software VMware. So that VMware is also available on cloud platform. There we can create. Suppose I am stopping this suddenly without shutting down. I am directly stopping this without shutting down. Simply I am saying power off. It will not affect on my Windows operating system. It will not affect on the Windows operating system. My operating system is perfectly fine. I close that instance directly without shutting down. Still, our system is working perfectly fine. So this is the advantage of cloud, where I can simply deal with the instances, I can get my job done, and with the help of that system, I need not to bring different operating system. I need not to bring different operating system. Through one operating system, I can do my job. That's all. Then up till now, we are talking about only advantages. But as you know, if there are advantages, there are disadvantages. Nobody is perfect, no system is perfect. If we are spending time on some good things, there are always bad things. So these are the bad things of virtualization actually. Now, I have shown you the example of virtualization on my computer system, where for that virtualization, first I have to install some software like VMware. It must have taken some space in my memory. Yes. Are you agree? Say 500 MB, 1 GB, 2 GB. That much space it has taken from my original storage capacity. So you have to spend for that. Then second, RAM. My RAM is limited 8 GB, 16 GB. And you might be knowing, if there is virtual machine and you have to store that virtual machine, that means you have to store all the intermediate states, all the intermediate files, all the intermediate data generated somewhere, and that somewhere place is RAM ultimately, because you have to store all the things, because all are the required things, all are currently in execution, and you are knowing that currently executing parts are there in RAM. So it is directly consuming your RAM. So if I have to store 100 virtual machines on my single computer system, it is not possible on this computer system. It is not possible at all. I can store at the max 5, 6, 10 virtual machines on this laptop. Otherwise it requires high capacity. So the first very major drawback, if you want to go for virtualization, you have to spend more on initial costing. Initial costing is very high. So in order to set up for that, you have to spend money on hardware, you have to spend money on software, you have to spend money on different resources, then networking. If there are 100 computers, your bandwidth should be more, so you have to purchase more bandwidth for your computer systems, for networking bandwidth, more high-speed networks, like that everything will be costly if you have to go for virtualization. But we have seen advantages of virtualization. So if we compare that advantages with this drawback, so it is just the one-time investment. It is just the one-time investment, and you can get all the money back within very shorter period of time. I can give you the best example nowadays in grid computing. In our upcoming slides, we have to see that grid computing as well. But nowadays, almost all the people are going for solar panels. And through those solar panels, they are generating electricity. And they are using that electricity for their houses. And if there is some extra energy generation through their solar panels, they are giving that energy to MSCB. And then MSCB is paying for them. MSCB is paying for them. So that is the thing here. If that solar panel requires 2 lakh rupees, 2.5 lakh rupees, so like that, 2.5 lakh rupees, like that, if we have to invest it once in upcoming 5 years, 10 years, definitely you will be in profit. But for initial period of time, you may feel that this is not of that use, and you may feel that it is not of a use. I invested 2.5 lakh rupees and my electricity bill is simply 500 rupees per month, and I am spending 2.5 lakh rupees. But if you compare it for larger, more span or more services, then definitely you will be in profit. So these things are there in cloud computing. Initially you have to invest, and if you invest, just keep patience, keep watching the things, and definitely you will be in well positioned and you will get profits out of it. So that is psychology is another drawback. Then the very important thing, lack of resources or the lack of skilled resources. Cloud computing is always hiring people. Why? Because they are hiring people. They are lack of knowledge or lack of expertise in those areas. That's why companies are again giving them trainings on different things. They are sending people in Japan, they are sending people in America, they are sending people in UK. Why they are sending those people there? To get some expertise out of there, get some expertise to enhance their skills so that company can be benefited. So always there is lack of skilled resources in this area. That's why cloud computing is very emerging area. Then if we don't have skilled resources, that means we have very less expert people available in our cloud computing domain. Definitely the people which are there and who are experts in that area, they will charge more, and they will create illusion in the system, in the society, that this is very hard, this is very costly, and you have to spend more money on that. And they are keep bombarding you like this because they want to earn more money from that. They want to create such a scenario that they are very important and they can charge anything that they want. But if there are skilled resources available, for one job there are 100 people, you might have observed, if there is more supply than the demand, the price drops. And if there is less supply and demand is more, the price is high. Agree? So if you have expertise in this area, you will be in a very comfortable position. And you can get your job very easily and you can get more money than anybody else in the market if you are expertise in this area. Then the very important factor, if you are providing access of your own resources to somebody, that means you have to migrate some data as well as you have to retrieve some data back to your cloud server. So it is transition of data. And if there is a transition, there is always a chance of security. security hole. Like bank is a resource for us, and all our money is, we are keeping that money in bank safely. Bank is providing us some extra service like ATM. But in order to provide that service, bank is hiring some agency, that is third party, and through that third party, they are putting money in those ATM machines. Am I right? Yes. So there is always a risk. Money is safe in bank, but it is not on the road. It is not that much safe on the road. Anything happens on road. Are you agreed? There is lot of risk outside the bank, but still we have to provide service. Still they are providing services. And you might have came across many such instances where always there are risk factors, incidents are happening, accidents are happening, and always there are chances of security hole, loopholes in the system, and it may go completely in different way. So these risks are always there in cloud computing, but still, if we are focusing on advantages, we have to focus on such disadvantages as well as we have to neglect it sometimes. So that is the important thing in cloud computing. Then, as I told you in the earlier video itself, that 4 different kinds of virtualization are possible. Different kinds of virtualization. Hardware virtualization, I told you the example of printer itself. Hardware is virtualized through different computer systems, and all the requests are placed in some queue. And as per those requests, our printer is doing printing job. Hardware virtualization. Operating system virtualization, just now I told you, I have virtualized operating system and I have created different instances through VMware only. So I have used different instances of operating system, and again through different software as well. Then server virtualization itself is the best example, Gmail, where you are hiring the services of directly server through some application. Storage virtualization, Netflix is the best example given, where they are taking services of virtualized storage space, and they are accessing those services through the storage. So like that, 4 different virtualizations are possible. 4 different virtualizations are possible. Let us see a small video for that, so that you can understand.
Hello everyone. Simulating hardware and software, such as computers, operating systems, storage, and networking. And it does it in a virtual or software environment. Now, the traditional way a business operates is by having one machine for one application. So, for example, let's say that a business has 3 servers, and they would have one of those servers dedicated to running an email service. And that server has Microsoft Windows as its operating system. And then that business would have another server that's used for running a website, and it would have Linux as its operating system. And then they would have another server that's running a database, and it's using Unix as its operating system. So one machine with one application. And in addition, those 3 servers are running 3 different operating systems.
Now here, in earlier scenarios, I have to use 3 different applications, and for that I require 3 different machines for those 3 different applications. Okay, earlier scenario, like email server is different, storage server is different, application server is different, and I have to invest on 3 different operating systems, on 3 different computer systems, as well as hardware, network for all these 3, storage spaces for all these 3. So it is large, huge investment in earlier days. Now what cloud computing and virtualization made possible, that is shown in the upcoming part.
But instead of having 3 servers running one application each, what if just one server could do the job just as good and do it more efficiently? So basically, one server would take the place of the three and run all the applications and even run their different operating systems. So this is what virtualization does. Virtualization is basically consolidating all of these physical servers with their different operating systems and applications and running them on just one physical server in a virtual environment. So now this one server is running 3 VMs or virtual machines. It's running all of the different applications such as email, web services, and databases. And they're all running side by side on one machine. But not only the applications, but it's also running their different operating systems side by side. And it's doing this all by using software. And it does it so well that when users interact with a virtual server, they would interact the same way as if they were still on multiple physical servers. They won't be able to tell the difference.
Now just see. Earlier it was shown that 3 different servers were required. Now, with the help of cloud computing server, we can create 3 different virtual machines on one cloud computing server, and we can place. So, काय होतं? We can place all 3 servers on single computer system. We can create 3 different instances with 3 different applications and 3 different operating systems, and plus host operating system is different. So in one computer system, instead of investing on 3 computer systems, I am investing small amount of money in only one computer system. I am paying for that one computer system only, and I can use like this. So this is the cloud computing and virtualization. Instead of using 3 different computer systems physically, I am creating 3 different virtual instances for 3 different applications as well as 3 different operating systems, and it can do work for me. So definitely, say for 3 computers, you have to pay say 40,000 rupees per computer, 1,20,000 rupees. Instead of that, I can buy one computer with good capabilities, say for 80,000 rupees. But if you compare 1 to 1, it is very costly. One computer for 40,000 rupees and one cloud computing computer is for say server for 80,000 rupees. So if you compare like that, it is very costly. It is very costly. But if you compare the total cost of your application, if you are investing in for 3 computer systems, it is 1,20,000. So instead of spending 1,20,000 rupees for the same job, if that job is done with only 80,000 rupees, so it is always better. If you think differently, you can get different outputs. It depends on your thinking. It depends on your business logic. It depends on your business skills. What you are thinking, where you have to invest, and it is the investment for one time only. Even if computer is having double cost, but still you have to invest.
Now we will proceed our article discussion session, and session will be till 1 o'clock. After that you have a lunch break for 1 hour. Please be on time. And before that, now we will start our article discussion session. Thank you. So please proceed further.
Are you feeling it interesting or boring? Tell it frankly. If you feel boring, you can raise your hand, you can stop me at any point of time. And you can tell it frankly. Because If you are not satisfied, if you are not happy, it is all in vain. It is all in vain. So please feel free, feel comfortable, feel relaxed. We are not, what we can say, we are professionals. So we have to think from this point of view. We are professionals. We are studying professional courses. We are studying it for our careers. So if you are not feeling comfortable, you can tell me immediately. If anybody want to go outside at any point of time, you can leave this place and at any point of time you can come back. So there is absolutely no restriction on it. Only thing is that you have to feel comfortable and relaxed. That's all. If you are in that mind state, you will get it more effectively. Otherwise, it is of no use. So instead of spending money on 3 computer systems, you have to invest money like this, and virtualization made it possible like this. So handling errors on 3 computer systems, it is always better to handle error on 1 instance or 3 different instances. Still your original computer system will work fine. Right? I told you that even if I close VMware instance, still my Windows operating system is working. And we are running our presentation, we are running all our videos on the Windows operating system. And at the same time we are using Linux operating system as well. So it is because of virtualization. And that is what virtualization brings.
Now, the software that creates and runs the virtualization is called a hypervisor. A hypervisor is what allows one machine to run multiple virtual machines. It allocates and controls the sharing of a machine's resources, such as storage space, RAM, CPUs, and so on.
How many of you? No, I think you are third year students, right? Is there any 4 final year students? How many of you? Raise big hands. Final year. Have you studied cloud computing? Cloud computing? So you might have came across this word hypervisor. Okay? So those who are new, you simply try to understand the importance of hypervisor. It is the core of the cloud computing. Hypervisor is the core. Because whatever hypervisor is telling, on that basis everything will be done by the cloud computing software. Without hypervisor it cannot be run. So hypervisor is the base. And what that hypervisor is doing, it allocates and controls the sharing of machines' resources. So it is acting as a mediator. It is acting as a mediator. And VMware is such kind of hypervisor. VMware is such kind of hypervisor. And through that hypervisor, it is possible to allocate storage space, RAM space, CPU space. So it can be utilized with the help of this hypervisor.
Hypervisors come in 2 different types. There's type 1 and type 2. A type 1 hypervisor is installed on bare metal hardware, meaning that there is no existing operating system or any other software on the machine.
Basically, 2 different kinds of hypervisors. Hypervisor 1 and hypervisor 2. Hypervisor without any operating system. Simply that piece of software is placed. That piece of software is placed. And then you can customize it as per your own need. You can customize, you can add, you can delete, you can scale up, you can scale down. Like that you can do anything. So there is no need of operating system. It is barely on the hardware. Simply on the hardware. And then you have to use it as per your own way.
Installed on empty bare metal hardware. A type 2 hypervisor is installed and runs on top of an existing.
So just little while ago, which type of hyperware we have used? Can you tell me? Hypervisor 1 I have already told you. Hypervisor 2 is in front of you. Hypervisor 2, type 2 hypervisor, requires operating system and it is built on top of host or machine operating system. So we have used VMware on top of Windows operating system. So we have used type 2 hypervisor. Type 2 hypervisor. I have shown you that while delivering PPT presentation, we have started one virtual machine as well, and it is on top of Windows operating system. So it was type 2 hypervisor. So we can use that kind of thing as well.
Operating system, such as Microsoft Windows, Mac OS, Linux, Unix, and so on. So the operating system sits in between the machine and the hypervisor. So as an example, let's go ahead and install a type 1 hypervisor on a machine. So let's go ahead and build our server that's going to be used to create virtual machines. So we'll start out with a server case, and then we'll install hardware in it, such as a motherboard, CPUs, RAM, and storage drives. So now our server hardware is built. So the next step is to install a type 1 hypervisor, and a common one is VMware ESXi. And that's going to be installed right on top of our bare metal server. So remember, there's no operating system installed on this server. It's empty. And then once the hypervisor is installed, it will be used to create virtual machines. So
It is installed on bare hardware. How many of you have seen such laptop on which no operating system is installed? And you might have purchased such kind of laptop. No operating system is installed. Simply it starts with C:, command prompt. That's all. Have you seen such kind of operating system? Nowadays all the laptops are inbuilt with Windows operating systems or Ubuntu or any Linux version, right? But in our early days, we purchased laptops where no operating system was there. It is barely a hardware, and on that hardware we have to install whatever we want. Simply here, in order to start that machine, simply an interface is given. That interface is hypervisor type 1. Then whether you want to install operating system on that, whether you want to use it for storage purpose, whether you want to use it for some application purpose, whether you want to install it like a network computer, it depends on you. A bare hardware is given to you, and in order to use that hardware, you require something. Like a printer is given to you, but in order to use that printer, you need to install some hardware for that, and without that, drivers for that, and without those drivers, you cannot use that printer. Or what else you can do? Simply you can print one test page. If you don't want to install that printer in your system, you need not to install drivers. That's all. In similar fashion, I simply want to show demo of my printer in my shop. I want to show this is the printer and this is the print quality. I need not to install my operating system. I need not to install my printer device drivers. Nothing. Simply there is one button, print, a test page will be automatically printed. So type 1 hypervisor is just like that. Simply a test page kind of functionality. A printer is given to you, whether to check print quality. It is not essential to install operating system. It is not essential to install device drivers. Barely I can check my hardware just by simple test page. Have you seen that? If you have not seen that, later on you can search such kind of videos on YouTube and you can see. But second scenario, if I want to use that printer for my lab and all 20 computers can work with on that printer, then in order to do that, what I have to do? I will need some different kind of hypervisor, some different operating system, some different functionalities, some different applications. Like, first of all, I need some operating system through which I can pass my commands. Second, I have to install device drivers on those computer systems so that all computers can interact with that printer and can place their request to print you, right? So barely hardware is given. Now I have to configure that hardware by my own way. So both the functionalities are possible. In a shop, I need not to install anything. Simply, customer is interested in testing the quality of the printing. So no installation is required. Barely, simply a test page functionality can print that page. If I want to use it for some specific purpose or for some specific printing, then in that case I have to install some additional thing. So that is type 2 hypervisor, where it requires extra functionalities. Now here, whatever I shown you earlier, that was type 2 hypervisor functionality.
Well, we'll go ahead and create 3 virtual machines. So first, we have to allocate the server's hardware resources to each VM, such as how many CPUs, how much RAM, how much storage space, and so on. And then once that is complete, we can load our different operating systems in each VM, such as Windows, Linux, and Unix. And then we'll install whatever service and application that each VM is going to run, such as email, a web server, and a database. And that's pretty much it. So these 3 virtual machines are basically 3 software-based computers. They all run just like a regular computer. They all have their own operating system, software applications, and allocated hardware. And each VM is independent of the other. So this was an example of a Type 1 hypervisor. Type 1 hypervisors are the most common because they are used in enterprise data centers. Some examples of Type 1 hypervisors are VMware ESXi, which I mentioned previously, Citrix Xen Server, and Microsoft Hyper-V. And as I mentioned earlier, a Type 2 hypervisor is installed and runs on top of an existing operating system. These are typically used on personal computers. For example, people will use a...
Now try to remember, we did exactly same thing on personal computer on top of some another operating system. So my base operating system is Windows 11 and through hypervisor we run Linux operating system through another piece of software VMware. So it is just like Type 2 hypervisor.
With hypervisor on their computer if they want to test out new software for research purposes or to try out and test different operating systems. For example, this Mac is running 2 VMs. One is Microsoft Windows and the other is Linux. Some examples of Type 2 hypervisors are Oracle VM VirtualBox, Microsoft Virtual PC, and VMware Workstation. So what are the benefits of virtualization? Well, the first benefit is that it saves money on hardware and electricity because a business won't need as many physical machines or the power that it takes to run those machines. It can just create virtual machines instead. And second, it saves money on floor space. A business won't need to purchase a lot of floor space to accommodate a large number of machines. Another reason is maintenance and management. Because by having physical machines, it requires administrators to maintain and manage a machine in case something happens, such as a change in the configuration or equipment failure, or maybe even a fire. And another reason is portability. VMs on a physical machine can easily be transferred to another physical machine if needed. So for example, if the current machine that is running the virtual machines is old and outdated, or if it's running out of space, those VMs can easily be transferred to a new and more powerful machine very rapidly, which makes things very convenient.
Another advantage of virtualization. I have created one virtual instance of Linux operating system. If you copy that folder from me, and if you want to use that folder on your computer system, say on this computer system, still you can use. You simply install VMware over there and open that image from there. It is simply just like that. So I can transfer my complete VM machine from one computer to another. I can clone that machine without any headache. You might be knowing cloning and copying are two different things. Cloning means creating exact identical image, and copying, we are creating some different copy of that image. So both the things are possible. Virtualization made it possible. Irrespective of, if you have VMware, you can use that image on any computer system. It is just like that.
Another benefit of virtualization is that it takes advantage of the full computing capability of a machine. And this is because today, computers and servers are so powerful that most of the time their full potential is not being used. The software applications that they are running are not able to utilize the machine's full potential. So the majority of the machine's power is not being used. But with virtualization, it can create virtual machines so it can push a machine's capacity to its limit and take full advantage of a machine's capability. And another reason is disaster and recovery. Virtual machines are just software files, and those files can be backed up and they can be uploaded to multiple physical machines. So if a machine goes down, the other machines will be there to take over. So I want to thank everyone for watching this video on virtualization. Please subscribe, and I will see you.
And this is the second type, operating system virtualization, where we can virtualize, create instances of different operating systems, and we can use those instances in full capacity, like a host operating system. So even if virtual instance is created, still it is having all the capabilities which a host operating system is having. So we can use with full advantages. A server utilization, virtualization, where, as I told you, we can create clones, we can transfer our settings, configurations from one computer, from one server to another server, one computer to another computer. So like that, we can create different virtual server as well. And we can create instance of server. So that server will work like a physical server. So there will not be any headache at all. And user will be in the illusion that I am accessing the original server. But in real sense, user is not accessing original server. User is dealing with the just the instance. And that instance is providing services to the user. Storage virtualization, where we can use different storage devices and we can place data, we can retrieve data, and we can have different operations on those storage. And in the morning session we have already seen Netflix is totally working on storage virtualization, where they are hiring cloud services for their storage spaces, and simply they are running one GUI through their application, and through that GUI they are accessing cloud computing services. So they are not bothering about their files, their movie files, their storage data, their softwares. They are not bothering about that. Simply what they are taking care about their GUI, about their website, about their application. Only they are taking care of those things. Rest of all the things are handled by cloud service providers. If some movie is not available at current point of time, immediately that request is thrown to some another server where that movie is available, and it is shown from that place. So in this way, cloud service can be virtualized and storage can be virtualized. So this is the basic architecture of virtualization and how different softwares are placed. Is it visible to all of you? Readable? Just have a look on this infrastructure of virtualization. So here, the difference is shown with the help of diagram, that traditional and virtual architecture. What exactly is the changes there in the existing hardware system? The first diagram is showing traditional architecture. We have hardware, then on that hardware operating system, and then application software. In virtualization, what we have? Hardware, then virtualization layer. Then if we want operating system, we can use that operating system. If we don't want that operating system, we need not to install. Like we have seen, hypervisor type 1 and hypervisor type 2. If we want, then we can install. Otherwise, we need not to install. So it is optional part. And then we can have applications on top of that. Clear? So instead of relying on operating system, one single operating system, we are relying on instances, and we have already discussed that instances are very lightweight processes, just like threads, and lightweight processes are always easy to handle rather than main processes. Main processes requires more efforts, more resources, more storage space, more RAM usage. So everything is more in regular processes. But if that process is lightweight, whatever we require, if we have only that much part with us, then we can handle that part very easily. Clear? So it is just like that. So here diagrammatically it is shown now. Type 1 hypervisor and type 2 hypervisor. Type 1 hypervisor is barely placed on top of hardware, while type 2 hypervisor is based on top of most operating system. And that example we have already seen with the help of VMware. Shall we take a break? It is already 12:30. घ्यायचा मॅडम ब्रेक? कारण मुलांना मेसचा काही प्रॉब्लेम आहे का? एक वेळा सांगितलं. Then we can continue. No problem. Now, very interesting concept. We can create virtual infrastructure. In similar fashion, we can create virtual cluster as well. Now, most of the students are going for projects or seminars, right? And for that purpose, sometimes you need to test your application, you need to test your algorithm, you need to test something, or you have gone through certain literature papers. And in those literature papers, you might have came across this word, virtual cluster. Virtual cluster. Like I want to create some regions nearest neighbor algorithm. There I have to create something virtually KNN. I have to create something For classification, I have to classify, I have to create different regions, and then I have to test. In similar fashion, generally in mobile computing and electronics and telecommunication field, this virtual cluster or virtual nets are playing very important role. First, they have to test their application through those virtual nets or virtual clusters, and then they have to test their applications. So creating physical clusters, it is not possible at all, right? Creating physical clusters, it is not possible at all. Like a mobile tower, and that mobile tower is the best example of this virtual cluster. So clustering is done, that through this mobile tower, this much area can be covered. So it is one cluster. Another, through different tower, this much area can be covered. Another cluster. So like that we can create many different clusters, and it is already created. Now what application I want to test? For example, say tomorrow there is one political function near to your college. So all the students, all the staff members are getting services through some mobile tower near to your college. Are you agree? So your timings are fixed, your registrations to that tower are fixed, and every day those are refreshed. That's all. Now what happens in such scenario if there is some political function here near to your college? Say 5,000 new people will come to your campus. They are coming with their mobiles. And they also require services from that mobile tower. And already capacity of that mobile tower is defined, and in what way you can provide services to them. So in that case, they need to provide virtual clusters. They will create instances. They will connect those instances to different towers. And even if that person is here in this region, through that virtual instances, that person is getting services from some another tower. Getting my point? So even if physically that network is not possible here, physically that resource is not available here, still those 5,000 people will get services. So in that sense, first they have to test in their company that what happens if 5,000 people will come in the network, whether our tower will serve or whether it will be problem to all, or how many people will require some other services. So what they can fire different algorithm, like whichever 4,000 comes first, give services from this tower. Whichever comes later, give services through some virtual instance, through some different tower. So like that they are handling their request. So in such kind of things, we need virtual nets or virtual clustering. So that virtualization made it possible without having actual infrastructure. You can create one instance, connect that instance to some different tower where utilization is very low, and give services from that tower. Rest of the work will be done by that tower only. Simply what company is doing, they are providing extra power to this tower through some virtual instance. If possible, that virtual instance will run on this tower only. If not possible, it will be connected to some another tower. Through some another tower, they will get services from there. So like that, we have to create virtual instances, virtual nets as well. So that virtual clustering is also possible. So here that scenario is shown. Physical cluster 1, physical cluster 2, physical cluster 3. We have only 3 physical clusters, and we can create their instances as it is, or mixture of instances or mixture of all the instances. Like I just told you one scenario, that this tower is not capable to give 5000 more services. In that case, I can cluster this tower with some another tower, and I can assume that as a single entity. Is it clear? I can assume single entity. So if you remember scalability, in this network, in this cluster network, I am adding one more tower. So my cluster is now increased, the size is increased. If both the towers are not capable of giving services, I can add one more tower, nearby tower, and now my cluster is fixed. And I am assuming that single cluster as single entity, the whole cluster as a single entity. Are you getting my point? First, initially in my cluster there is only one tower. That one tower is good enough to give you services in this region. 5000 more people will come at any point of time, and your tower will fall short to give services to all such newcomers. Then what company will do? Create a virtual cluster. Through that virtual cluster, they will add one more tower in your network. Now, the region will be increased. So your cluster is having now 2 towers. If again 5000 more people will come, again you will feel that you are not getting services. One more tower will be added. So like that scalability. If that function is over, that cluster is again removed, and your cluster is just of single tower only. So it is just like scaling up, scaling down, and in this way virtual clusters can help us. But what the person, the newcomer person, feels that it is getting all the services, uninterrupted services. But at actual, what is happening behind that is virtualization. Is that clear? It is virtualization. Because of virtual instances, it is possible. If we have to provide new services physically, then in that case we have to install new tower here. So just for the function of one day, is it possible to install new tower? So why to waste money if virtualization is possible? Why to waste money? You simply create virtual instance of this tower and give services to that virtual instance through some another tower, and still you can get services. If your purpose is over, you remove it from the system. You delete that virtual instance. That's all. It is that much simple. I think we can take a break, and after break we can go for the next part, grid and cloud computing, right? Or if you have any doubts, if you have any queries, you can ask. आता सोडायचं 15 मिनिटांनी 15 मिनिटांनी सोडायचं का आता? ठीक आहे. If you have any doubts, if you have any queries, if you want to share something, if you want to ask something, you can ask. Anything in your mind, any application you know, any algorithm you have studied,